This is section 15.8, drawing an expected proton NMR spectrum of a compound. So in the book, there is an example of how to draw an expected NMR spectrum, but instead of doing this exact example, let's do one that's slightly different together so you have more opportunities to have some directed learning. So what if we had a molecule that looked like this? Let's not do that. Let's do this. Here we go. There's an alcohol. Here we go. We have this molecule. It has a molecular formula C1, 2, 3, 4, 5, 6, 7. So it's C7, H3, 4, 6, 7, 10, 13, 16. Oh, okay. And to solve or to draw the expected spectrum for this, first we need to find out how many signals that we would expect to have. So let's mark with a different color how many different signals we would expect. So we would expect there to be 1, 2, 3, 4, and 5 different signals for this molecule. Each of these CH3 groups here, the ones I'm highlighting, those are all equivalent. Those are homotopic. But the other 4, the ones that I'm circling now, they are all unique. So we would expect there to be 5 different signals. What about the number or the multiplicity of each signals we would expect? So if we draw this in purple, for the one labeled 1, we would expect that to be a doublet called, we'll write D, because its nearest neighbor is only 1 hydrogen, right? We would expect that 1 hydrogen neighbor to be a complex doublet and doublet. So maybe something that looks kind of like a quartet. It also has a third neighbor, so it would be a little difficult to say what the splitting of that molecule would be or what that proton would be. The one marked 3 here, it would have just 1 neighbor, so it would also be a doublet. In number 4, it also has 1 neighbor, so it would be a doublet. And these protons here, number 5, they would all be singlets because they have no protons in their nearest neighbor. And for the integrations, we would say that number 5, I'll write them in green. We would say number 5 should be equal to 9 protons. Number 4 should be equal to 2. Number 3 should be equal to 1. And number 2 equal to 1 as well, with number 1 being equal to 3 protons. That equals up to 16. And so now we could potentially draw the expected spectrum after we look at where these shifts should come out. So we should expect the shifts of these molecules or these protons, these around 1, I think we're 1.3, something like that, around 1.3 ppm. Number 4 should probably be around 1.5 ppms or so. Number 3 will probably be around 1.4 ppms, something like that. Number 2 should be around, I think it's 4 ppms, around 4 ppms. And number 3 should be around 3 ppms or something, I believe. That's correct. So these are all the ways that you can use a molecular structure to try and predict what an HNMR spectrum would look like. And these shifts, I just took off the top of my head, so they might not be all correct, but they are around what you would expect. This has been section 15.8.